everybody. Today we're going to be looking at factors in prime factorization. I do want to say that this is just looking at numbers in terms of factoring out what makes a number composed of different digits in order to find common denominators, greatest common factors, all those types of things that we'll do in another video. This is not looking at trinomials and binomials and factoring them like the pre-algebra stuff. We will do a video of that in the future, so keep an eye out for that. But this is really just your basic type of factoring and prime factorization that you would see in maybe like 4th, 5th, and 6th grade. So it'll help you out. It shouldn't be too tricky. You definitely want to know your multiplication tables, but we're going to break it down and use a couple techniques that have seemed to be successful for kids in the past. Please make sure that you're subscribing, commenting, sharing, and all that. It would really help me out. Otherwise, I hope you enjoy it. Have a great day. All right, here we go. Let's see. What we're going to do is list all the factors of each number. Now, I have had kids say that they have teachers call what's called the rainbow method, which seems to work really well. So we're going to look at 15. All right. The obvious is that we're always going to use 1 here. All right. And then 1 times the 15 go hand in hand. So what we do is we draw a little arch there, or loop. All right. And then we go right down the number line, 2. 2 is not going to work, but 3 would work. So we have 3, and then we ask ourselves, well, what was it times 3 that would get us to 15? And that's 5. So we put that here. Next is 4, and then now we're at 5, so we're pretty much done. So our list goes along like this. We can see we have our little loops there, looking more like a rainbow. 1, 3, 5, and 15 would be our only numbers. All right, now we're going to look at 24. Once again, we'll start with 1, and we'll start with 24 at the back. We'll draw a little loop. All right, we go down the number line, 2. Yep, 2 will work. 24 is even, so 2 times 12 got us that. 3 will work as well. 3 times 8 will get us that one. Make sure we're drawing our loops here. And then we have 4. Well, 4 times 6 will work as well. And then 5 puts us in the middle, but 5 will not work. So our list is 1, 2, 3, 4, 6, 8, 12, and 24. All right, let's look at 87 now. This is a little tougher. All right, so we're going to have 1 and 29. Oh, I'm sorry, 1 and 87. All right, that's our probably most obvious. Now, we're going to take our timer because this is a little overwhelming, all right, especially for the younger kids. We go with 2. All right, I want to do a video on number tricks later on, and it may already be up there, which will help you out with factors of numbers. All right, so if you look, this is not an even number, so 2 is not going to work. So what we're going to do is we're going to go to 3. Here's the trick with 3, and to see if 3 can go into a number. What we're going to do is add 8 and 7, which is 15. Well, guess what? Since 3 can go into 15, 3 can go into 87. Now it's just a matter of figuring out what times 3 got us to 87. Well, if you do 3 times 29, it will actually get us 87. And then from there, that's the only thing that's going to work. So we have 1, 3, 29, 87. So keep an eye out for that video, okay? The next one is 36. Once again, we'll start with 1, 36, we'll connect that. It's an even number, so we know 2 is going to work. And remember, when we're using 2, it's like we're asking what's half of that. So 2 times 18, 3 would work. 3 times 12, we'll connect that. All right, we use 4. Yep, guess what? 4 is going to work too. 4 times 9. 5 will not work. And then 6 puts us in the middle. 6 times itself will get us to 36. So there's a lot there for this one. So we got 1, 2, 3, 4, 6, 9, 12, 18, and 36. I don't think I missed any. All right, now this is slightly different from what they asked before. They don't want a list, but they want us to write the prime factorization of each number. All right, so we're going to use what's called a factor tree. All right. It's not your traditional type of tree. So you can start anywhere. We're asking ourselves, what 2 numbers could we multiply together to get 44? I must state that you're not going to use 1 because you're just chasing your tail at that point if you're using 1. So we always go to 2. All right, it is an even number, so we can use 2. And that's like saying you're taking half of 44. All right. Now, this 2 is not going to be broken down anymore, so we put a circle around it, stating that we're going to stop. All right, this number's even as well. So let's go with 2 again. 2 times 11. All right. Prime means the number can only be divisible by 1 in itself. So that holds true for all these numbers. So when you go to list it, we're saying 2 times 2 times 11. When the numbers repeat, we're going to write those as exponents. So 2, we saw this happen twice. There's 2 2's there, so that goes to the second power times 11. There's your final answer. All right, let's try 56. All right, so we can go with 2 again. All right, it's an even number. 2. That's like taking half of it, which half of that would be 28. We can take half, or break that down by 2 as well. So we have 2. Half of that is 14. Still even. We can break that down. 2 times 7. Well, prime. So 2 times 2 times 2 times 7. So we see 3 of these 2's here. So it's 2 to the third power, which gives us 8 times 7. Boom. 56. All right. And this other one we have here, 100. All right. So we're going to use 2 again. 2 times 50. We can break this in half. 2 times 25. All right, now this can't be broken in half, so you got to know your times tables here. What can you multiply by to get 25? The only thing is 5. 5 times itself. So 2 times 2 times 5 times 5. So it's 2 to the second power times 5 to the second power, and we're good to go. All right, here's a great real-world example of looking at prime factors and factorization. So it says John has an assigned seat for his flight to New York City. The seats on the plane are numbered 1 to 49. So already with this are numbered 1 to 49. It's got to be a number in between that. All right, that's our first constraint. John's seat number is an odd number. All right, another constraint. So it's only going to be about half of what 1 to 49 is. So 2, 4, 6, 8, 10, all those are not going to work. They are not odd numbers. All right, it's an odd number, but it's also greater than 10. So we know that 3, 7, 9, all those are out. All right, so we're left with odd numbers between 11 to 49. All right, so odd numbers greater than 10, but it's also a factor of 100, meaning that this number could go into 100 if we multiplied it by something. So let's go down the list. 13, can't multiply that by something to get 100. 15, nope. 17, can't multiply that. 19, nope. 21, can't multiply that by anything. 23, nope. 25, 25 times 4 could get us 100. All right, so that's our answer right there, 25. Great example of a real life situation using prime factorization.